Good day, learners. Welcome to our mathematics lesson. My name is Nagile Ndlovu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Okay, boys and girls, welcome to our today's mathematics for our day. Our focus for today is going to be trigonometric equations. Right, our lesson objectives for today are as follows. By the end of this lesson, you should be able to determine a general solution to a given trig equation, of course. 2, you should be able to determine a specific solution to a trigonometric equation by using the given interval. In other words, these are restricted intervals or restricted solutions. 3, you should use known identities to substitute and simplify in a trigonometric equation. Number 4, you should be able to use a reference angle to determine either a general solution or a specific solution to a trigonometric equation. By now, I would have expected you to be knowing the following: Cartesian plane, trigonometric identities, trigonometric graphs, which are very, very fundamental in general solution. Then period of a trigonometric graph. After how many degrees does the same cycle repeat itself depending on the given function, whether it's sine, cosine, or tangent. You should be able to also interpret intervals. We have seen quite a lot of these intervals when we are looking at the domain of a function, the range of a function, and just drawing of graphs in general. We don't draw them in the entire interval from minus infinity to infinity. We normally identify a particular interval and observe the behavior of our graph. Then factorization by using common factors. We have seen factorization a lot in algebra. It will follow us again in trigonometry, like you saw under simplification of trig expressions. Then simplification of expressions, obviously we're talking of trigonometric expressions here, and then substitution. Right, by definition, we're saying a trigonometric equation is an equation involving one or more trig ratios of unknown angles. Then a general solution of a trigonometric equation is a solution which represents all the solutions which satisfy the given equation. A specific solution of a trigonometric equation is a solution which represents angles found in a particular interval. Here we are not looking at all the angles that satisfy the given equation. We are going to be given a specific interval to say, for instance, from minus 180 degrees to 380 degrees, which angles can satisfy this given equation. Then a reference angle is always a positive acute angle lying in the first quadrant and can be used as a model for angles in other quadrants. In other words, after having found this reference angle, you can use it to generate other angles that make the statement true. An acute angle, we have defined it before as an angle which is greater than 0 degrees but less than 90 degrees. In as far as the Cartesian plane is concerned, in as far as your quadrants are concerned, this angle is always found in the first quadrant. Then trigonometric substitution is the replacement of a trig function for another equivalent expression. Right, the question is, how do we solve trigonometric equations? Step-by-step solution of a trig equation. 1, you need to start your question carefully and then apply known identities where necessary. Some questions may not require identities. They may go straight to algebraic manipulation, which is factorization, multiplication, addition, subtraction, and division of terms. So otherwise, your second step will be algebraic manipulation. Always isolate or solve for the ratio first. You'll have to isolate your ratio. Is it tan, is it cosine, or is sine? Sine, yes. So you need to isolate it so that you are solving for that particular ratio. Then eventually in number 4, you solve for the variable by using the inverse function and write your answer in general form. Otherwise, you use the interval if the solution is restricted. Then take note of this. It is always helpful at times to change from sine and cosine and sine to tangent. Whereas previously when we were simplifying, we were saying it is important to change tan to sine and cosine. This time around, in some equations, you'll find that you are forced to convert two functions that are involved in the equation. It could be sine and cosine that can be converted to tan. So this time around is the reverse operation of the quotient identity. And of course, you must always check your solution. Okay. Right, so we are going to have a look at an illustration here to say what we mean by a general solution. Unfortunately, your diagram has been distorted here, but nonetheless, we'll just continue. Right, what we mean by a general solution. I'll start with the sine graph to explain what we mean by a general solution in a particular interval. So in this case, we want to find the general solution to the equation sine x is equals to 0.5. Right. So if we were to graph this in the interval negative 360 to 540 degrees, we want to see how the sine graph behaves. We were taught graphs in grade 10, how to draw these sine graphs, and you'll remember the sine graph has got a domain of some kind. For today's lesson, our domain at the x element of is a closed interval from negative 360 degrees up to 540 degrees. So we have chosen an interval here. This is our domain for today. This is our domain. Okay. Then we move on to our range. Remember, the range for a standard sine graph are the y values for which the graph exists. So our range is going to be y is an element of, we check where our graph starts. Our graph starts at -1 and stops at +1. That is our range. So meaning our range is -1 to 1. This then will lead us to what we call the amplitude of our graph. Amplitude of our graph of sine x. Our angle is x. So our amplitude is half the distance between the minimum and the maximum. So half the distance, our amplitude is going to be 1. It's half the distance between the upper value minus the lower value. So your amplitude in the actual fact is going to be 1 minus -1 is the upper value minus the lower value is always half that distance, which gives us 2 over 2, which results in a 1. So it means our reference line is the x-axis. Our graph gets displaced to the top values of y and to the bottom values of y as it oscillates between -1 and 1. Our graph is going to move up and down between -1 and 1. So we say our sine wave oscillates between -1 and 1. That is a standard sine graph, wherein here you have a coefficient of 1. It's 1 sine x. As long as it is 1 sine x, our graph will always be trapped between -1 and 1. So if you were to graph this on a Cartesian plane, it will display what you see right now. So what we are saying here, it starts at -360 is 0. Then we move up with this point is the turning point at 1 there, which is our -270. Then we come in the middle here. This is our -90 degrees. It is at -1 and so on. At 0, the function is also 0. Then at 90 somewhere here, our y value is a 1. In other words, sine 90 degrees is 1, and so on until we get to the last point in our closed interval, which gives us 540 degrees. So what then do we mean by sine x is equals to half? Yes, we are comparing two graphs here. What we are saying here is that we want to compare these two graphs and see what happens. So what we're basically saying here, we are given that sine of x is equals to 0,5. This indirectly means that we have got two functions that are equated. We have got probably f of x is equals to sine x, which can be sketched on a Cartesian plane, and then the other graph is g of x equals to 0,5, which is a straight line graph. This is a straight line graph. It's a straight line graph. This is a straight line graph. It's not in the form y equals to mx plus c. It's y equals to 0,5, which means it's a line that is parallel to the x-axis. This line is parallel to the x-axis. Parallel to the x-axis. So we are going to sketch both graphs on the same Cartesian plane. So sketching both graphs on the same Cartesian plane means we have the sine graph, which is this black graph. Then this is your y is equals to 0,5. Right, as you draw this broken line across, you'll find that it cuts the graph in so many different points where I've marked here in these stars. That's where they meet each other. So here they meet each other in 1, 2, 3, 4, 5, 6 different points in the identified interval, which is negative 360 degrees to 540 degrees. So basically we're saying, where is this sine graph equals to the line y equals to 0,5? It's like we've equated two functions. So we want to know, when did these two meet? You can see they meet somewhere here, they meet somewhere there, they meet here, they meet here, and before 0 they meet twice, after 0 they meet 4 times. So what does this further imply? Remember, it's us who chose this interval. We chose the interval and stopped at 540 degrees. In essence, this graph does not stop at 540. Remember, it runs from negative infinity up to positive infinity. This graph will always be there. This line y equals to 0,5 will also be there. So these graphs will be meeting from minus infinity up to positive infinity. All the way through from either side, the two graphs will always meet. So where they meet, it means they share those x values. That's what we mean by a general solution. So in a general solution, you will not exhaust the solution. Why is it difficult to exhaust the solution? Is because the sine wave does not stop. It runs from negative infinity and continues up to positive infinity. This graph will forever be oscillating between -1 and 1 endlessly to either side. The same applies to the line y equals to 0,5. It will behave the same endlessly from minus infinity up to positive infinity, from negative infinity up to positive infinity. So meaning these two graphs will forever be meeting for the rest of our lives, because the graphs don't stop, the lines don't stop. They will continue moving up to positive infinity, continue decreasing down to negative infinity. So at any given time, they will meet at some points. So where they meet are the solutions to those two, sine x equals to 0,5. So in this case, our interval was specified. We are saying these two graphs will meet. We are focusing on the interval for x element of negative 360 degrees up to 540 degrees. So we want to observe how many times these are going to meet. Where they meet will then give us our solutions. Then the question is, how do we proceed from there to find the angles where they meet? So step number 1, you are going to say sine x is equals to 0,5. This is upon calculation. Otherwise, if you are using a proper graph paper and you have drawn these two graphs on the same Cartesian plane and did not measure them, these will meet at 150 degrees, they will meet at 390 degrees, they will meet at 510 degrees, they will meet at 30 degrees, they will meet at negative 210 degrees, they will meet finally at negative 330 degrees. So meaning those are your angles. So in the interval, our solution using the graph paper, our solution will have to literally read the answers from the graph. So in this case, they met at, we collect our answers using the curly bracket, they met at negative 330 degrees. That's where they met. They met again at negative 210 degrees. They will meet again at 30 degrees. According to this graph, they will meet at 150 degrees. They will then meet at 390 degrees. They will continue and meet again at 510 degrees. They will continue meeting forward and backwards. But because we were working with what we call a restricted interval, what does that mean? It means this then becomes your solution, because we are observing the graph between minus 360 degrees and 540 degrees. Then we read where they meet. We go down and read there, that's your 510. You go down and read your answer, that's your 390, then your 150, and so on. This is when you have chosen to solve this question graphically. So what we are looking at is called a specific solution. But this specific solution can also be interpreted as in general solution, meaning why do we call a solution to this a general solution? Because this graph does not stop like I indicated earlier on. It continues up to infinity, to either side. Then the line, this broken line, will also continue up to infinity. So meaning these two graphs will forever be meeting. And we can generate answers where they meet. So since we can't write down all the solutions, we'll then call that solution a general solution. There is a special way of representing that general solution you shall see as we continue. But one thing that I need to emphasize is that when you talk about these graphs, they have what we call a period, meaning from minus 360 we go up, down, down, then up, then we stop at 0. We have moved 360 degrees up to 0. It's like the same wavelength starts again from 0. You go up, it's like going up this side, down, down, further down, up, and stop. So this cycle, let me highlight that cycle. This cycle here will always continue in this format. That's your first cycle. Then your second cycle will start again. Let me choose this color for you. The second cycle starts there. It moves, continues, bends, stops again there. So this red is a complete wave. Then green is another complete wave. These waves are basically the same. It started from the horizontal, it went up, it came down, crossed, further down, stopped, then up, down, further down, stop. This is what we mean by the period of a graph. It is the period of a graph. The graph will repeat itself after a certain number of degrees. So the period of the sine graph is always 360 degrees. So it means if these two graphs meet at negative 210, because of the behavior of the sine graph, we will have another solution after a revolution moving forward. We keep on adding 360. You add negative 210 by plus 360. You can add there and see what it gives you. Negative 210 plus 360 and see what you get there. you will find that you generate the next angle. So you press on your calculator, your negative 210, you add 360 degrees, mine gives me 150. So it means from negative 2, the next angle they will meet again at 150. When you are at 150, you add 360 degrees, moving forward, it takes me to 510, which is this last point they meet in the interval. If you add 510 plus 360 degrees, it takes you to 870. You keep on adding a revolution. And alternatively, when you start from negative 210, you subtract 360, you're getting negative 570. You may not see it because it's after or further below negative 360. Our interval stops at negative 360. But if you subtract these revolutions backwards, you generate many other answers going back. Hence, that's what we mean by a general solution. A general solution means you are giving us a solution that represents all the values that are possible to give us a 0,5. Basically where the sine graph will meet the line 0,5. Okay, then let's proceed. Now, if you are now to find your answers versus calculation, how do you do it without a graph paper now? We want to solve this equation without using a graph paper. You always draw your Cartesian plane. This is 90 degrees. This is 360 degrees, a complete revolution. Remember, angles are measured in an anti-clockwise direction. This is our Cartesian plane. So how do we solve this for the same angles that we were talking about? So when you are finding the general solution in this case, you are going to say, isolate the ratio. I have already isolated sine, so I need to solve for the variable which is x. You pull down your x and you introduce what we call the inverse of tan, which is, sine, which is read as arc sine of 0,5. Arc sine of 0,5. This arc sine of 0,5 will give us an angle. So when you press arc sine of 0,5 on your calculator, you are going to say shift second function sine, then it gives you arc sine of 5, then you fit your 0,5 and get your 30 degrees. So the moment you say arc sine of a particular number, the answer should always be an angle. In this case, it's a 30 degrees. And you can see it's a positive acute angle, meaning I can use it as a reference. It's a positive acute angle. Therefore, it can automatically become our reference angle as we solve this question. So what does that mean? It means we need to go back and check where is sine a positive. According to this, we all remember the cast diagram. All students take chemistry. So in this diagram, where is sine a positive? Yes, sine is a positive in the first quadrant and second quadrant. So we are going to use our reference angle to generate answers in general form. So we are going to say our first solution, this can be referred as a reference angle. So it's going to be 30 degrees, that is in the first quadrant. So it means those angles that will be generated from the first quadrant will be led by 30 degrees. Plus, you add the revolutions of your period, 360 degrees. So it means 30 degrees will be used to add 360 moving forward or to subtract 360 moving backwards. So in the first quadrant, our angles are going to be represented or be led by 30 degrees. So 30 degrees will generate its own angles. So in this case, these are 30 plus k, 360 degrees, where your k is an element of integers. Remember, your integers are 0, 1, 2, 3, moving forward, or -1, -2. So these are the values that you substitute with going backwards or forward. So if I use a 1, you put k is 1, it becomes 360 plus 30. which is your 390. You saw 390 already. There it is where they meet. When will they meet again using 30? You add twice 360 plus 30. You keep on adding 360 moving forward depending on where was your last point. So this is what we mean by a general solution. It means this 30 degrees plus K 360 can be used as a model to generate more angles that make this statement true, moving either forward or backwards. Starting with 0, you substitute, you get 30 is your first angle where they meet. Use a 1, they will meet at 390. If you have a restricted interval, you hunt for all the angles that fall within that interval, playing around with this statement that you have just written down together with K element of integers. When we say K element of integers, it means you'll be replacing your K to find multiples of 360 as you move forward to generate more angles that make the statement true, or move backwards using the negative ones to generate. For instance, when K is negative 1, you are going to say negative 1 times 360, you get negative 360. Then you add 30 degrees, you get negative 330. So it means they will meet here at the last point, which is your negative 330. That's how you generate those angles. So from the way we have done it here, this is what we call a general solution. That's our general solution in sine. But we did not exhaust the quadrants. This 30 is in the first quadrant. Where else is sine a positive? In the second quadrant before 180. So your next solution is x equals to 180 degrees minus 30 degrees, which is your reference angle, plus K 360 degrees for the same reason, K element of integers. When you work this out, you'll find that this leads you to x equals to 150 degrees plus K 360 degrees. So it means here are other angles that will be led by 150 degrees, which is in the second quadrant. So 150 will generate its own angles, meaning these graphs will meet also here at 150. Then that 150 will generate its own other angles. So the answers that we have obtained here are called general solution, because they don't give specific values. Otherwise, if I want specific values, I need to have an interval of operation. And in this case, my interval was negative 360 to 540 degrees. So I will then have to substitute for the K values to get the angles that fall within that interval. Okay, you will see as we proceed. Otherwise, let's have a look at the second question, which says tan squared x divided by 3 minus 1 equals to 0. The first thing that you do here is to isolate the ratio. In other words, solve for tan first. Just like any other equation, we are going to use the additive inverse, add 1 to both sides, then cross multiply, you'll get tan squared x is equals to 3. Then you take square root of both sides. When you take square root of both sides, you'll have on your left hand side tan x equals to plus or minus square root of 3, which is approximately plus or minus 1,73, correct to 2 decimal places. Then from here, what are we saying? We are saying if we draw the graphs here, when you draw the graphs, you are going to draw the tangent graph versus the two values of tan x, which is plus or minus 1.73. So we have drawn the tangent graph, which is a standard tangent graph. It passes through 0, 0, and remember the tangent graph has got what we call lines of asymptotes. These are your lines of asymptotes. The graph does not cross this line. It doesn't cross this line either. These are our lines of asymptotes. Then at 270, we have another line of asymptote. Line of asymptote. There we go. These are lines of asymptotes. Minus 270, another line of asymptote. like that. So this is the tangent graph. We have drawn it, but we're specifically focusing on tan x is equals to plus or minus 1.73, meaning we've got two lines here. One line will label it as y is equals to 1.73, which is above 0. The other line is y is equals to negative 1.73. So we want to know where these two lines are going to meet our tangent graph. Where they meet are our solutions. They meet here, they meet here, they meet here. All these are solutions within this interval that we chose. So if I was using a graph paper, I would literally read all these marked points. Those are the answers where tan x is plus 1.73 or negative 1.73. It's a 2-in-1 because of plus or minus. It was a quadratic expression. When we solved it, there was a plus or minus, either a positive value or a negative value, because it's a squared function. So first things first, what did we do? We solved this equation for the ratio, which is tan x, underlined in red there. Then we didn't divorce ourselves from algebra. Then we take square root of both sides, then simplified. Tan of root 3 is approximately correct to 2 decimal places, plus or minus 1.3. We then sketched our tangent graph as shown here, then drew our lines of asymptotes, the lines which the graph does not cross. Then we drew our two lines, y equals 1.73, which is a line parallel to the x-axis, cutting the y-axis at 1.73. Another one will cut the y-axis below the 0 line, or x-axis at negative 1.73. So where these meet is what we mean by our solution. And they are going to meet again up to infinity. These solutions will never stop. They will continue, but we need to understand one thing. What is the period of the tangent graph? Yes, the period in the tangent graph is always 180 degrees. How do I know it's 180? It's either you use lines of asymptotes or use the graph itself. If I take the graph here at 180, the next branch I see at 0. So the gap from here up to there is 180 degrees. The gap from here up to there is another 180 degrees. So basically, our graph keeps on repeating itself after every 180 degrees. So when you find the general solution of the tangent graph, you must always use the period of 180 degrees. Okay. Right, let's move on to our first question here, which says determine tan x minus 1 divided by 2 equals to negative 3. Right, so we're saying tan x minus 1 over 2 is equals to negative 3. This time around, I'm not going to sketch the graph. I'm going to solve the equation algebraical to generate the answers where these will meet. So first things first, I'm going to cross multiply. I will have tan x is equals to negative 6, multiplying both sides by 2. We're using the multiplicative inverse of half is a 2. Then there is a minus 1. Let me so long add a 1 there. Okay, tan x is equals to negative 6 plus 1. We have transposed the 1. Alternatively, we can take it step by step so that you are not lost. Tan x minus 1 equals to negative 6 upon cross multiplication. Then our tan x is going to be negative 6 plus a 1. Then we have isolated our tan x equals to negative 5. That's your step number 1. Always solve for the function first. Then from there, you solve for the variable, which is x. But I've always advised that for you to understand this thing better, rather use your quadrants. This is 90 degrees, this is 180 degrees, this is 270 degrees, which doesn't feature a lot, then this is 360 degrees. Right, you have to identify where tan is a negative. Tan is a negative in the second quadrant and fourth quadrant. That's where tan is negative. So we are going to solve this equation and find the angles that make the statement true, and we need a general solution. We don't want all the angles, we don't want specific angles. We want all the angles that make this statement true. That's what we mean by a general solution, because there is no interval. So how do we proceed from there? We find what we call a reference angle. We explained earlier on to say it is an acute angle that you can use to generate many other angles by knowing in which quadrant you are. So our reference angle is equals to a positive angle. So you say arctan, inverse of tan, then you introduce your 5. You leave out your negative if you are finding the reference angle. There are two ways of answering these questions, but I prefer the reference angle so that you understand how we use the reference angle to generate the answers. So in this case, what we are saying, what is our arctan of 5? You take your calculator, you press your arctan of 5. When you press your arctan of 5, you press shift on your Casio calculator or second function on your sharp calculator. Then press tan. It will produce arctan, as you see on the screen there, arctan of 5. That is read as arctan or inverse tan of 5. Then you press the equal sign. It will give you 78.69006753 degrees, which is approximately 78.69 degrees, correct to 2 decimal places. So step number 1, what you do when you are finding the reference angle, you look at the number involved. If it's a negative 5, you leave out the minus. Then you press second function if it's a sharp calculator, or shift if it's a Casio calculator. Shift tan. The moment you press shift tan, it doesn't press tan, it presses the inverse of tan. The inverse of tan is the one that helps you to get an angle. So arctan of 5 gives us 78.69 degrees. That's what we mean by a reference angle, which is an angle less than 90 degrees but more than 0 degrees. It's always a positive angle. Then how do you use this angle to find your solutions? Okay, right, there is our question. To find our solutions, we already said we have our quadrants here, 90, 360, as well as 180 degrees. Then tan is positive, negative here, and in the fourth quadrant there. That's where tan is negative. And your reference angle is 78 degrees. So if I'm in the second quadrant here, I'm going to say, therefore, my x as a solution is going to be 180 degrees, and then minus my reference angle, which is your theta. Remember, this is 180 degrees minus theta. So we subtract that 69, then add your period for tan, which is 180 degrees. Then you proceed and simplify. What is 180 minus what we have there? We getting 101 degrees. It's actually 101.31 degrees plus k times 180 degrees. Why do we add k 180 degrees? For k element of integers. Why do we add that? This is the period of the tangent graph. It keeps on repeating itself after every 180 degrees. So it means the statement that we see right now is called a general solution. All answers are in this statement. It now depends on which answers you want. If you want a specific interval, then you create that interval. Then keep on substituting for k, starting with 0, 1, 2, 3, moving forward, -1, -2, moving backwards, and generate many more angles that make the statement true. So meaning we have found our general solution is 101,31 degrees plus k 180 degrees. This is our general solution. Right, one will then argue and say, but we still haven't found the other solution, which is in the what? In the fourth quadrant. You will realize that when you are dealing with tan, there is no need to go to the fourth quadrant. It's already represented here. Why? Remember, the period in tan is 180. So if you move from this quadrant, I'm going to draw a line there. If you move from this quadrant to this quadrant, is exactly 180 degrees. Meaning, when you add 180 degrees, you are adding half a revolution. So it's going to take you from quadrant 2 to quadrant 4. So all angles that are in quadrant 4 are automatically covered in this statement because of half a revolution. You are not making a complete turn. When you make a complete turn, you come back to the second quadrant. But since you are making a half turn, which is 180 degrees, if I was in the second quadrant and I add 180 degrees, I go to the fourth quadrant. So I don't have to say 360 degrees minus 178.69, my reference angle. Remember, here is 360 degrees minus theta. We can do it, but you'll find that all those angles are already in this statement. For instance, a learner who goes on to say 360 degrees minus 78.69 degrees plus k 180 degrees, which is the period in tan. When you subtract those two, you are going to get 281,31 degrees plus k 180 degrees. You will realize that here, when you go back to this line, let me highlight it for you. When you go back to this line here, right, if I substitute for k using 1, I'm moving forward. It's going to be 180 degrees times 1, which gives us 180. Then you add 101.31, I'm getting 281.31. So meaning this general solution of 101.31 degrees plus k 180 already contains 281 when we substitute for k equals to 1. When you put k equals to 1 here and add 101.31, it gives us 281. So meaning, as you move from this quadrant all the way around 180 degrees, you have already arrived in the fourth quadrant because you are making a half turn. You are not going to skip that particular quadrant. That's the advantage of tan. The advantage of tan is that your quadrants are always across each other, vertically opposite each other, which is a half turn. And the period also agrees with that half turn. So for that reason, with tan, you don't have to worry much about the quadrants because one quadrant automatically takes you to the other quadrant. Okay, only when you want to use a revolution would you consider both sides. So those of us who want to use a revolution, this is how you use a revolution in tan. You find your first answer, you got your x equals to 101.31 degrees plus k 360 degrees. You are also allowed to add a revolution in tan. Remember, adding a revolution mass does not affect the direction. So some other learners can work it out with 360 degrees. This means you are moving from one quadrant and coming back to the same quadrant. So if our 101 is here, This is our 101.31 degrees. You are going to move all the way around and come back to this point. All the way around and come back to this point. So it means you'll never stop in the fourth quadrant if you use a revolution. So in this case, you'll be forced to find those angles that are generated in the fourth quadrant. So once you use 360, know you're moving from one quadrant and coming back to the same quadrant. It doesn't pass through the fourth quadrant because you are making a complete turn. So turn can be answered with 360 degrees, which is whereby you are looking at generating angles from the same quadrant, using 101 to generate angles only from 101. Then you go to the fourth quadrant, or our x is 281.31 degrees plus k times 360 degrees. For k in both cases, elements of integers. So should you decide in tangent to use 360 degrees instead of 180, you should show both solutions, because either solution takes you all the way around and you come back to the same point. So once you commit yourself to 360, make sure you consider both quadrants where that particular function is negative or positive. Okay. Otherwise, it is always sufficient to use 180 degrees plus k element of integers. That half turn takes you to the other quadrant. You don't have to find this other solution. Okay. Right, let's proceed. Our next question says 3 sine x equals to 2 tan x. These are the types of questions where you need to apply your knowledge of identities. It's for 6 marks. We are asked to determine the general solution. 3 sine x equals to 2 tan x. Let's proceed to that question. What do you think is the first step here? We have two functions in one equation. It would be very difficult for us to isolate either tan or x because they will block each other. So let's not forget our quotient identity. We are going to say 3 sine x equals to twice sine x divided by cos x, if you still remember the quotient identity. Then from there, we are going to multiply both sides by, or cross multiply. We basically have 3 sine x times cos x equals to 2 sine of x. We can proceed to the other side and say, let's form an equation, 3 sine x and equate it to 0 times cos of x, then minus 2 sine of x is equals to 0. What do you notice at this level? Yes, we realize that sine is common, so we factor out sine x. We are left with 3. This is where you need to use your skills of algebra. Minus a 2 equals to 0. That's where we are. We're going to take it from there. Sine of x times 3 cos x minus 2 equals to 0. Then we apply the 0 principle of multiplication. So we're saying sine of x times 3 cos of x minus 2 equals to 0. Then apparently there are two functions this time. We separate sine x, either sine x is 0 or 2, it's actually 3 cos of x minus 2 equals to 0. Then we take one at a time. We solve for x here. We are going to go back to our quadrants. Then let me start with this one. We bring down, let's find our reference angle, which is equals to arc sine. Every time you find the angle, you say press inverse sine, second function sine or shift sine of 0. It's a number. Then this will lead us to 0 degrees. If you press that on your calculator, it gives you 0 degrees. That's your reference angle. Then you go to your Cartesian plane. This is 90 degrees. This is 180 degrees. And then this is 360 degrees. And then otherwise, this is 270 degrees. Then you say to yourself, okay, where is sine a positive? We'll treat that 0 as a positive. Our reference angle is 0. So sine is positive here and there. We're actually on the margins. So we're going to say our reference angle is 0. So our solution will be x equals to 360 degrees plus 0 is still 360. So it's going to be 0 plus 360. That's our angle. It's 0 degrees added to k 360 degrees. Okay? Then that gives us our k 360 degrees. It's multiples of 360 for k element of integers. Never forget that k element of integers. Let's pause on this one for now. Then we proceed and say, okay, this is one general solution, which is our first quadrant. Then we go to our second quadrant, it's 180. So our x is going to be 180 degrees minus your reference angle. Your reference angle is 0 degrees. But you have to add your period in sine is 360 degrees. So the other angles are going to be 180 degrees minus 0 is still 180 plus k 360 degrees. This is our general solution for k element of integers. So we have two positions where we can draw our answers from. It's either the answers will come from the first quadrant or from the second quadrant. Those that come from the first quadrant are led by 0, and those that come from the second quadrant are led by 180. Then you generate many other angles by using the period for our sine. Then we go to the other side. Remember, our other side was saying, let's take the screen. The other side was saying 3 cos of x minus 2 equals to 0. Then we solve for cos of x. 3 cos of x equals to a 2. Divide both sides by 3. Both sides by 3. Our cos of x is equals to 2 over 3. This is what we mean by isolating the function. We have isolated our function. Having done this, you'll have to solve for x now. Therefore, our x is going to be, before maybe we get to x, let's talk to the reference angle. This is the angle that you are going to refer to find your solutions. It's going to be arc cosine of 2/3. You'll then take your calculator, you press your arc cosine of 2/3 and give me the answer. What is arc cosine of 2/3? Second function, cosine, it will bring that cos with a negative 1 at the top. That is read as arc cosine or inverse cosine of 2/3. It means one and the same. Inverse cosine of 2/3. I'm getting 48.19 degrees, correct to 2 decimal places. It's approximately 48.19 to 2 decimal places. This is our reference angle. It's not the answer. It's our reference angle, meaning we are going to use this 48 to generate the answers. That's why we call it a reference angle. Then you go to your cast diagram. It will guide you. I prefer this. I've seen people skipping it, but it plays a vital role in you mastering and grasping the general solution. Then you say to yourself, where is cosine a positive? Because this is positive 2/3. What do I mean by a positive? It is a positive 2/3. So positive 2/3 means the value of the cosine is a positive value. So cosine is positive in the first quadrant and fourth quadrant. That's where it's positive. And we have our reference angle. Automatically, that reference angle becomes an answer. At the same time, let's not forget in cosine, NB, take note of this, in cosine is allowed. In cosine, cos of theta is the same as cos of negative theta. So now that I have 48, I can as well say my x as a solution is going to be plus or minus 48.19 degrees plus k, the period of cosine is 360 degrees for k element of integers. This is a complete solution in as far as the cosine graph is concerned. That's a complete solution. When you say plus or minus in cosine, it's acceptable because cosine is positive in the first quadrant, is also positive in the second quadrant. In the fourth quadrant. But remember, cos of theta is the same as cos of minus theta. Minus or negative 48.19 degrees is in the fourth quadrant. It was measured in a clockwise direction. That's your 48.19 degrees measured in this direction. Then on the other side, that's your 48.19 measured in the anti-clockwise direction. So cos of negative 48.19 means you are measuring your angle in a clockwise direction. Cos of 48.19 degrees, you are measuring it in the anti-clockwise direction. Both values will have the same answer. Hence, we are taking advantage in cosine alone to say x is plus or minus. The moment you say plus or minus, you have answered the question for both quadrants. But otherwise, if you don't want to use plus or minus, you can still say your x equals to 48.19 degrees plus k 360 degrees. Or you go to the fourth quadrant, x equals to 360 degrees minus that 48.19 degrees, then plus your k 360 degrees. This is where, if you want to separate the two and have different solutions. So you take your calculator, you say 360 degrees minus your 48.19 degrees. It gives us 311.81. It means those are the angles that are in the fourth quadrant. They will be led by 311.81 degrees plus k 360 degrees for k element of integers. That's what we mean by a general solution in this case. So it's either you separate them. If you don't want to separate them, you use the first answer, which is 48.19, and just say plus or minus and stop there. It's a complete solution because even that 311.81 is already covered in this plus or minus 48.19 degrees plus k 360 degrees. But should you decide to represent them quadrant by quadrant, you'll be forced to find that 311.81. It will generate its own angles. Then 48.19 will generate those that come from the first quadrant. Okay, so that's how you could have marked for you. 1 mark for sine over cosine, 1 mark for factors, 1 mark for both equations, then 1 mark for your general solutions. There are your general solutions in the event that you choose to separate the answers. And then if you decide to put your answers as 1, you can so long write it as at the bottom there, plus or minus 48 degrees. The approach will be the same, but upon getting your 48, you will say plus or minus. All right, let's move on to the next question. Our next question is a November 2015. It's a past exam paper. It's a November 2015 paper. It says consider the expression 1 minus cos squared A divided by 4 cos 90 degrees plus A. That is the first part of the question. Simplify to a single trig ratio for 3 marks. We are not dealing with simplification, but along the way there is simplification. The question that we are really targeting is 5.3.2. Hence, determine the general solution of the equation 1 minus cos squared A divided by 4 cos 90 degrees plus A equals to 0.21. Okay. Right. The first thing is to check. We need to simplify 1 minus cos squared A. Let's put it down. 1 minus cos squared A divided by 4 cos of 90 degrees plus A. We want to simplify before we can talk of forming an equation. Simplify. There is a reason why the examiner is saying simplify. This is where we said you need to understand your identities. You will remember our square identity, cos squared A plus sine squared A, what we normally call the square identity, is always identical to 1 or equals to 1. Then I can manipulate this and write it in 3 different ways, meaning I can say sine squared A equals to 1 minus cos squared A. But remember, this can also be written as cos squared A equals to 1 minus sine squared A. You must never forget those variations. Now, having done this, what am I saying? I see in the numerator is 1 minus cos squared A. I'm going to replace my numerator and use this middle one. Let me choose green color for you. Right. This part here doesn't want to choose. Okay. Right. Let's take this middle part here. Okay, it's fine. We're taking this middle part there. We substitute here where we see our 1 minus cos squared A. We are going to put sine squared A divided by 4. We stop there. We think of cofunctions. Cos 90 degrees plus A. We need to check in which quadrant is 90 degrees plus A. Yes, it is in the second quadrant where cosine is a negative. So this will reduce to negative sine of A. Then we simplify further. This goes to sine squared A divided by negative 4 sine of A. We have multiplied there. Negative sine A times 4 is negative 4 sine A. Then we simplify. We can divide easily here. This will then give us negative 1 over 4. Remember, there is a 1 there. Coefficient of sine squared, there is a 1. So it's negative a quarter. Then we divide this and 1 goes negative. That sine of A becomes our simplified part. This is worth 3 marks. So it means the whole of this thing here simplifies to this part there. Our 1 minus cos squared A divided by 4 cos 90 degrees plus A simplifies to a negative quarter of sine A because of cofunctions and the square identity. This is how you can play around with your trig identities to simplify trig functions. Then we move on to 5.3.2, which says hence. When they say hence, they are saying using the previous result, solve this equation. We already know our previous result. We are going to say in our previous result, we have 1 minus cos squared A divided by 4 cos of 90 degrees plus A is equals to 0.21. But from our previous result, we realized that this is negative a quarter of sine A. That's what we mean by hence. Use the previous result. It makes your life easy now, and you just have to isolate your sine A. Isolate your function. Then we multiply both sides by 4. We will get negative sine A is equals to 0.84. When you multiply both sides by that negative sine A, we're getting sine A equals to 0.84. Let's check our question. Yes. Then we proceed. Our negative sine A equals to 0.84. We divide throughout by negative 1 to get sine A is equals to 0.84 negative, like that. Yes. Then from there, we are going to find our reference angle. Our reference angle is going to be equals to inverse sine of 0.84. Don't put the negative because this is a reference angle. Then you take your calculator and find your reference angle, which is second function or shift sine then of 0.84 is a second function sine. Then you put your brackets, 0.84 close brackets equals to 57.14 degrees. My reference angle is 57.14 degrees. That's my reference angle. Having found your reference angle, you go to your Cartesian. This is 90 degrees. This is 180 degrees. I find it easy with this diagram. And then this is 360 degrees. Then you check where is sine a negative. Must always go back and check the sign there. Sine is a negative in the third and fourth quadrants. So meaning we have to have answers generated in the third quadrant and other answers generated in the fourth quadrant. But fortunately us, we already have our reference angle, which is 57.14. So here we have 180 degrees plus theta. Here we have 360 degrees minus theta. Your theta is your reference angle. That's your theta in this case. So what we do, we proceed and say, therefore our x first answer is going to be 180 degrees plus you add your reference angle, 57.14 degrees, and then plus k 360 degrees for k element of integers. That's general solution. Then you add the 2 and get 237.14 degrees plus your period k 360 degrees for k element of integers. Or on the other end, your x is going to be 360 degrees, which is now the fourth quadrant, minus the same reference angle, 14 degrees, then plus the same period, 360 degrees. Then you simplify and get your final answer, which is 302.86 degrees plus k 360 degrees, which for k element of integers. This is now your complete solution. So there were two possible quadrants that would give us our answers. So it means there are answers that will be generated in the third quadrant where sign is a negative. There are again going to be other answers generated in the fourth quadrant led by 302.86. So in general, all those solutions will be represented by those two statements. X equals to 237.14 degrees plus K 360 degrees for K element of integers, meaning we are generating in the third quadrant. Since we are adding a revolution, we're coming back to the third quadrant. So it means we need to also find other angles where sign is a negative. Otherwise, if you leave out the other quadrant, your solution will be incomplete. You'd have taken only from the third quadrant and left out all the other angles that are in the fourth quadrant. So you have to go and use your theta there, which is your acute angle, 57.14, and separate it from 360, because all angles that are in the fourth quadrant are 360 degrees minus theta. Your theta in this case is your reference angle. So it's easy when you work with a reference angle, then go and identify your quadrants and either add or subtract that reference angle depending on the quadrants that are affected. Okay, so this is how you could have answered that question there. So there are your solutions for those angles. Mine had a 2x there. Mine didn't have 2x, mine had only an A. Only an A there. Okay. Then we move on to the next question. This is going to be our last question for the day. The question says, solve the equation 3 sine squared theta minus 5 sine theta, then cos theta equals to 0. In the interval, theta is an element of negative 180 degrees to 180 degrees. This one is not a general solution. It is a particular solution. This will take us to a specific solution, meaning we'll have to find those angles that are within that interval so that we are controlled. We are restricted today. We don't just work out. We have to work them out in a particular interval. All right. How do we proceed on this question? Step number 1, what do you notice? Look at the question. Yes, this looks like a simple equation, although it's in terms of trig functions. We are going to factorize. We factor out sine theta in this case, into 3 sine theta, 1 sine theta remains, minus 5 cos of theta equals to 0. Okay? Then we are going to separate them. Let's start with the first one. The first one is sine theta is equals to 0. Let's focus on that for now. We'll come back to the other one later. Let's focus on sine theta is equals to 0. Again, what did we say? We'll have to check where sine is a positive. Sine is a positive in the first quadrant and second quadrant. Otherwise, this is your 90. This is your 180 degrees. This is your 360 degrees. Then 270 degrees. Then from there, what we do, we find our ref angle before we find our theta. Reference angle. Please, when you are finding the reference angle, don't say theta or x. Just write ref angle. You find the inverse of that value. Then it gives me 0 degrees. Then you go to your general solution. Your general solution will then now say theta equals 0 degrees plus K 360, which is your first quadrant. And then theta is equals to 180 degrees in the second quadrant minus theta. Your theta is 0, your reference angle. Then plus again K 360 degrees for K element of integers. So this gives us 180 degrees plus K 360 degrees. That's the complete solution for k element of integers. Right, so we'll generate our answers from this one so far to check which ones fall within the interval. Then you move on to the next one. Our next one is going to be 3 sine theta minus 5 cos theta. So we're going to have 3 sine theta minus 5 cos theta equals to 0. I'm going to move 3 sine theta equals to 5 cos of theta. I'm going to then divide both sides. Let's divide both sides by cos of theta, cos of theta. We mentioned earlier on that sometimes it's necessary to change sine and cosine to tangent. This will then form 3 tan of theta, sine divided by cosine of the same angle, equals to 5 times 1, which is a 5. Cos divided by cos, this cos. Then divide both sides by 3, therefore tan theta, you are now isolating the function is 5 over 3. You're getting 5 over 3. That's what we're getting there, 5 over 3. Then from there, we find our reference angle, which is equals to arc inverse tan of 5 over 3. Fortunately, it's a positive value. So you take your calculator, you press second function tan, it will say arc tan. You introduce a bracket, then you fit your fraction 5 over 3, and then close and say equals. I'm getting my angle is 59.04 degrees, correct to 2 decimal places. That's our reference angle. So we then go to our Cartesian plane and identify where tan is a positive. Tan is a positive in this quadrant and in the first quadrant. Oh, this is where we said half a 10. So just one solution is sufficient. So we are going to say 360 there and then 270 here. Once you make a 180 degrees turn, it takes you to the other quadrant. So you don't need both quadrants this time around. So what am I going to say? Tan is positive in the first and third quadrants. So in the first quadrant, we have 59.04 degrees. So what does it mean? It means our theta is going to be 59.04 degrees plus k 180 degrees, which is the period in tan for k element of integers. I don't have to find the other quadrant because once I move from here a half turn, it takes me to the other quadrant. So it's already covered. And then that quadrant is after 180. You're basically adding 180 to 59. It will take you straight to where else tan is a positive. So tan is a positive here, sine is a positive there, all are positive here, otherwise cosine is there. So these are vertically opposite quadrants. So it's an angle of half a 10, which is 180 degrees, and it agrees with your period. So the two answers from the two functions that we obtained are as follows now. We have the first answer was theta equals to 0 degrees plus k 360 degrees, right? The other answer was theta equals to 180 degrees plus k times 360 degrees. We have found another answer, theta equals to 59.04 degrees plus k times 180 degrees for the tan. So if you now want to search for which values of theta that lie in the interval minus 180 degrees to 180 degrees. You'll have to use your k now. Suppose I put my values of k here. This is going to be k values 0, 1, 2, minus 1, minus 2. I want to search the answers. What happens? Are they within? So when k is 0, we normally prefer to start with 0. When k is 0 on the first one, this gives us 0 degrees. When k is 0 on this one, it gives us 180 degrees. When k is 0 on the last one, it gives us 59.04. So you substitute for 0 in each one of them. This is your theta in each one of them. Then when k is 1, you go back. When k is 1 on the first one, is 360 degrees plus 0 is outside your interval. You leave it out. You come to the second one. When k is 1, is 360 plus 180 is also outside. When k is 1, all of them are outside. So all these won't be taken. They are beyond the interval. They are beyond the interval. So I'm not going to list them. They are beyond the interval. When k is 2, is even worse. I'm not going to continue that side. I come to -1. When k is -1, the first one is out, meaning it's 0 degrees plus -1 times 360 degrees. Yet the cutoff is -180, so it's out. In the second one, when k is -1, this is 180 minus 360, which is -180. That one is in -180. It was a closed interval. For the next one, when k is -1, I'm going to get 59.04 minus 180 degrees. It gives us -120.96 is in. -120.96 degrees is in. Then when k is -2, they are out. Therefore, our solution, theta is equals to, we collect all those that are within our interval. I see -180 is in degrees. I see -120.96 degrees is in. I see 0 degrees is in order. Then I see 59.04 degrees is in, and final 180 degrees is also in. So these are the only angles that are in our interval that satisfy our given equation. So you always test your k values to see if those angles fall within your interval from -180 to 180. Answer by answer, or general solution by general solution, where you keep on replacing your k, simplify, and see if it's within. So when k is 0, you put a 0 throughout and see how are those angles behaving. 0 will be in, 180 will be in, 59.04 will be in when it's 0. When it's 1, check which ones are in. If they are still in, check the 2 when k is 2, up until you have exhausted all the angles that the examiner wants. So what we see here is an example of what we call a particular solution. This is a restricted solution. We don't want a general solution. We want angles that lie within a specific interval. Otherwise, you can't get those angles if you don't start by finding the general solution. So whether it's general solution or specific solution, you need the general solution. Okay. All right, so there is your worksheet. Your worksheet is marked out of 30. The first question says determine the general solution for 2 sin x cos x equals cos x for 6 marks. Number 2, which is B, sin 2x plus 45 degrees equals to -0.22. Go and attempt those questions. C, 2 tan 2x minus 15 degrees equals to 9.48. Then 2, solve the following equations in the given intervals. 3 cos squared x plus 11 sin x plus 1 equals to 0 in the interval x is an element of negative 360 to 360. 5 tan squared x plus 7 tan x is equals to 6 in the interval negative 180 to 360. Otherwise, the last question is cos x minus 12 degrees equals to sine 23 degrees in the interval 0 to 360 degrees. In summary, what did we look at in this lesson? We were looking at the general solution to a trig equation, that is finding a specific solution to a trigonometric equation by using the given interval. We also used the identities to substitute and simplify in a trig equation. We used the identities like the square identity and the quotient identity, which says sine over cosine is equals to tan. Then 4, we were also using a reference angle to find either a general solution or a specific solution. Then we also had a look at a step-by-step solution of a trig equation. We said step number 1, you must always apply known identities when necessary so that you are able to simplify. Having substituted and simplified, you have to algebraically manipulate your equation, either in factorization, multiplying, adding, subtracting, and dividing terms. Sometimes you need to divide to create a single function, especially where there is sine and cosine. You can divide both sides of the equation by cosine to create a tangent. Then 4, solve for the variable by using the inverse function and write your answer in general form. Otherwise, you use the interval if the solution is restricted. Then it is always sometimes helpful, like I have already indicated, to change cosine and sine to tangent. Otherwise, it will be difficult for you to solve the equation if there are 2 functions in one. Then having done whatever manipulation, whatever substitution, it is always advisable and wise to always keep on checking, tracing, and tracking your work to see if there are no errors. Otherwise, you need to remain focused because it will affect the answers towards the end. Trigonometry requires concentration. Otherwise, you will spoil the work all the way down if you don't keep on checking. Thank you for attending. We'll meet again at some other point. Thank you.